So in the process of playing with the PID with the actual physical elevator last night, I realized that it would be a little complicated to get multiple cameras synchronized with each other so that I could show you the set point, process value, and control value of the Arduino in real time with the motion of the elevator hardware. So I realized that I have a strip of 300 Neopixels that I used for Christmas lights and decorative lights recently. And I can hack off those Neopixels into a strip of, say, 15, whatever it is that fits on the board, and use those as the indicators. But since I'm going to use it, I wanted to introduce you to it in a short video. So, nice to know that Tinkercad has Neopixels. So let's do this. If you go into circuits and you create a new circuit, and you bring an Arduino onto your circuit and change this to advanced or all and look up Neopixels, you'll see that Tinkercad has a bunch of Neopixels. They have individual Neopixels that you can put anywhere you want, and they have some of the rings, and they have strips in various lengths. You can pick pretty much any of these. I'm going to start with a ring, and we'll go with the Neopixel ring 24. So this is 24 Neopixels that are serially controlled and serially connected to each other. Now what that means is that, like this Neopixel, this single Neopixel, there is an input, which is the data line that will connect to the Arduino. There is a ground connection and a power connection. This can be 5 volts. It works at 3.3 volts, but we're going to go with 5. And the data in here controls this Neopixel. But then if you take a second Neopixel and you connect the out of that Neopixel to the in of the next Neopixel, and the ground to ground, and the power to power, then what happens with the library in Arduino is the data that you send to this Neopixel gets used by this Neopixel. But then if you send a second data set for the color of a Neopixel, then this Neopixel will send what it originally got as its information to this Neopixel. And the second set of data will show up on this Neopixel. So if you program it to do Neopixel 0, the first one connected to it, be red, and Neopixel 1 be blue, what will actually happen is the library will tell this Neopixel initially to be blue, but then it will send out additional data for this Neopixel to be red. This Neopixel will get the data that was going to be blue for this Neopixel, and when you tell the library to show the Neopixels, all of them will come on at the same time, with this one being red and this one being blue. And it doesn't really matter how many Neopixels you have in series, except that the more Neopixels you have to control, the more data has to be pushed out, and the slower the response time will be. Controlling 300 Neopixels is still actually pretty fast. So the way these rings and strips are connected is they're just a strip that's been formed into a circle with a first Neopixel in series with the second, third, fourth, on up to the 24th. So what's that look like when we control the Neopixel? Well, if we get rid of this and get rid of this, or maybe we'll keep it actually. Yeah, let's just arbitrarily keep 3. We'll do 3. So out to in, ground to ground, power to power, ground to ground, power to power. And on the ring, we have power to, let's say, power, ground, in, and out. So So let's organize this a little bit differently. I'm going to rotate the Arduino so that the power is on the left. So ground to ground, and power to 5 volts. The in I know that the default for the library is pin 6. So that's the data coming out of the Arduino to feed the Neopixel. I'm going to feed both of these in parallel. So here is the input that is also going to come from D6. Ground from ground, and power from 5 volts as well. So both these three in series and the ring, which is 24 in series, is going to get the exact same data. Now, Tinkercad doesn't seem to have any libraries that are easily accessible, so we can start Arduino, and I already have the Neopixel library installed, but if you needed to install it, you could go to Include Library, Manage Libraries, type in Neopixel, and just grab the Adafruit Neopixel library, whatever version it currently is. The current version is apparently 1.7. I have 1.6 installed, so let's update that to 1.7. So now in the Arduino IDE, if you have a library installed, you can go to File, Examples, scroll down to Examples from that library. Adafruit Neopixel, and let's do a strand test and see if this works. Again, we have the library, LED pin 6, and the LED count, well, the ring is 24, but let's limit it to 12 for the moment, just for illustration's sake. If we copy this entire code and then paste it directly into Tinkercad, ideally this should work and the library should be available. Cool. And it is in fact. Now let's greatly simplify this. You need a program to include the library, the Neopixel library code that needs to be sent to the Arduino so that the commands down below can be used. So the LED pin that it's connected to is 6. This is where the data comes out. We are telling the library that we're only using 3 pixels. So there's no point in programming the 12th or the 100th or the 300th, and saves time. When it sends the data out to the strip, it will only send out 3 pixels worth of data. We create an object that is the Neopixel strip. The Neopixel needs to know how many LEDs, what it's connected to, and the type of LED. In setup, we initialize the library, which is just like initializing the serial library if we want to talk over the serial console. Strip clear is a function that quickly fills all of the colors of all of the strip to 0. Strip.show is the function that actually pushes the data out and shows the data that we've sent to the strip. Until you execute this, the strips will not actually light up or change. This is an internal library bit that you can use to set the maximum brightness of your LEDs. This is mostly useful if you're using a lot of LEDs and you want to make sure that you don't accidentally set it so bright that you draw too much current and it damages things, which includes the Arduino itself, since right now we're using the power from the Arduino that can only supply up to half an amp. 24 Neopixels is not an issue. 300 Neopixels is several amps of current at maximum brightness. The pixel number that we're going to control with the command is pixel 0. We're going to set the red value between 0 and 255, 255 being maximum red, green, blue. Strip.set pixel color is the library function that you use to set this pixel to this color. This is a library function that takes the three 255, 255, 255, so 3 bytes, and puts it together into a single 24-bit piece of information that the library understands how to send out to the Neopixels. And then finally, just like up here, where we cleared the strip and then showed the clear strip, after programming the color for the LED, we have to send the data out to the LED. So at the moment I'm setting pixel 0 to be black. If I haven't made any errors, the LEDs should just be off. And I'm missing the closing curly brace for the function in setup. So all LEDs are off. Let's set pixel 0 to be bright red. Let's set pixel 2, which is the third pixel, 0, 1, 2, to be purple. Red and green make yellow on the middle pixel, pixel 1. You'll notice that we're doing this in setup, not in loop, so it shows that once you've written a value to the Neopixel strip, you don't have to keep hammering it to keep it lit up. It won't change again until it receives more data. So if we were to take this code and put it in loop, make this pixel a random pixel, and let's just randomly assign blue. So red's on, green's on, blue is random. And finally, we'll add a little delay of 1 second between updates. That's kind of boring. And since we do actually have a strip of 3 in parallel with a strip of 24, let's give it the ability to control 24 with a much shorter delay. 10 random colors to random pixels per second. So my intent with this is this. I'm going to use a straight strip of LED Neopixels, and I'm going to make the set point the green, the process value the blue, and the CV, the control value, to the motor, red. And the floor that the elevator is moving towards is going to be bright white. Have fun.